Alright, so in this video I'm going to show you how I solve the state machine exercise. It's usually a little bit better to try to solve it yourself, for the learning experience and so on. But if you're stuck or you're, I don't know, watching this on your mobile phone, you are of course welcome to just watch me implement it. And yeah, let's jump into Unity and Visual Studio. Okay, so this is the program I've provided you with, and you can see we've got a ninja, we've got a bunny, and we can move by pressing the arrow keys. We can move our ninja, and he can also jump. And we now want the bunny to stay at a certain distance to the player and move towards him if he's too far away, or move away from him if he's too close. So we're going to try to solve this by using a state machine. So we are going right into the code. Now, the first step is just to create 3 states. First, the idle state, the run towards state, and the run away state. And we're going to use this, of course, with a state machine. So let's do this right away. Here I've got the rabbit, and I'll create first the enum. Okay, and I'll set this enum to the idle state at the beginning. All right, that was easy. So we've already finished exercise 1. Now let's continue with exercise 2, the state logic. Now, as I've already shown in the previous video, we're going to create a separate update method for each state. And we're going to call each of these update methods if the enemy is currently in the corresponding state. So let's get coding. Okay, so I've created the methods. Now let's also create the switch statement so you can also see how that works. Okay, so now we're switching between the different states. If the enemy is in the idle state, we call the idle update. If he's in the run toward state, we call the run toward update. If he's in the run away state, we call the run away update. However, those states don't do anything just yet. And now, in order for them to move the enemy actually, we're going to use this method that I've already prepared for you. It's called setVelocityX. So let's get back to Visual Studio and implement that. Now in update idle, I actually don't want to move the enemy, but in run towards, I definitely want to move it. So we can call now the method setVelocityX, and this method requires a parameter, and that's the speed at which it should move. So we could use -1 to move it left, or +1 to move it right, or +15 to move it very fast to the right. And I've created a few variables here, and we're going to use this running speed to actually move this guy. However, this now moves it towards the player. We can use the same thing to make it move away. However, here we need minus running speed. Come to think of it, exactly the opposite, because it needs to move left to the player. So let's try this out. If we hit play, the enemy doesn't do anything. That's of course only logical, because it didn't, we didn't set the state to anything but idle. So just in order to test it, I'm shortly going to make this public. We'll change this back right away, but just to test it, let's make it public so we can change it. So back in Unity. And of course, I also need to make the enum itself public. And now, yeah, now I can change it. So let's hit play again. And if I set it to run toward, it moves toward the player. Run away, moves away from the player. All right, that seems quite fine. So let's get back to idle. And the next thing that we need to do is to implement these state transitions. And I already did this for you. By the way, I highly recommend to not just start coding, but rather before you code, think about your AI and draw one of these state diagrams where you can already find a few problems that might come up. So this is a really simple case, but usually those transitions aren't that simple, and it can be very useful just to have a diagram and just think about all the edge cases that can come up. So yeah, we're going to check this out. So let's start with the idle mode. Now, first of all, we also need to set the velocity in the idle update. So we're going to call set velocity x to 0, because if we don't do that, and it was previously in the run towards, and it then gets to the update idle, the speed would still be minus running speed. So we need to reset it to 0. That's clear, I hope. Next, we need to think about a few things. Now, we will check if the enemy distance, this is a variable that's automatically calculated here in the update method, and this is just the distance to the enemy in meters. And if this enemy distance is greater than the max distance, we will set the current state to rabbit_state.run run toward. Now what this means is if the enemy is too far away from the player, it moves toward the player. So if the distance is greater than the max distance, it moves toward the player. All right. Now let's code the transition back to the idle state if it has finished moving toward the player. Now, if the enemy distance then becomes smaller than the max distance, we will set the current state to rabbit_state.idle. And then we do the same for the runaway state. So we ask if the enemy is too close to the player, we let it run away. And then we need the transition back to the idle mode. So if it then has moved far enough away, so it has reached its minimum distance, it will go back to the idle mode. Now save all of this. Let's refactor it slightly so it's a little bit better. All right. Now go back to Unity. And let's try out what happens. Now at the start, the enemy keeps coming. And you can see it tries to keep up. And if I move closer, it doesn't do anything. But if I move too close, it goes back until it's at the edge of the world. And if I then again move away, it again tries to keep the distance. Now, if you're Mr. Fancy Pants, you can also add a few animations here. I'll do this right away. So to do this, we are going to set in the idle mode, we can say animator dot set integer. We can set the integer anim to 0 to make him idle, or to 1 to move towards, and 2 to run away. Now let's check if this works. Yeah, and here's the run animation. Let's go close to him. Yeah, he runs backward, which looks a little bit strange, but it works. Yeah, and that's really all that there is. So congratulations, we finished the first basic exercise where we just created a very simple state machine. Now in the next video, we're going to look at how we can improve our code so it's a little bit better reusable. And we're going to do this by implementing the state pattern. So I will see you in the next video.